having a good afternoon session. I'm really excited for this talk, so I was glad I got to be in here. We'll be joined for this session with Brian Vecci. Brian supports a wide range of security and technology initiatives by helping Varonis' customers and partners get the most out of his company's products. In his 20-year technical career, he started as a developer, tech architect, engineer, product manager for companies in financial services, legal, and cybersecurity. Brian joined Varonis in 2010 in technical marketing, led education and development, and now serves as the company's field CTO. He holds a CISP certification and frequently speaks on topics related to security and technology. He has been quoted in news sources ranging from the Financial Times to Dark Reading and has made multiple appearances on CNBC. So we're really honored to have him here sharing this hopefully very interesting talk on hacking the cloud. No pressure.
Thank you. No pressure at all. Hopefully very interesting. All right, hi everybody, my name is Brian. I'm the field CTO at Varonis. I'm not gonna spend a lot of time, or really any time, talking about Varonis today. What I am gonna spend a lot of time talking about is how a threat actor can get access to a pretty typical cloud environment, establish persistence, elevate privileges, move laterally, and of course, nobody breaks into a bank to steal the pens, get access to and steal a whole lot of data in a lot of different places. This is a lot of fun. I'm going to give you kind of a play-by-play. I'm clearly not actively driving the attack that you're going to see. There's a lot of recordings. There's mouse moving across the screen. I'm going to give you a play-by-play, describe what's going on, and then we're going to flip things around and kind of do our own little, just with us together, a little purple team so you can see what this looks like. All right, so here's what you're going to see today. We're going to do some really basic, easy reconnaissance. I'm going to be using some shell scripts. I'll call that out, and you'll see what the script is actually doing. I know this screen, especially for you in the back there, is a little bit small, so I'm going to walk you through what you're actually seeing. I'm going to do some reconnaissance. I'm going to find some digital secrets that are exposed. I'm going to use those to get access to a directory, establish persistence, elevate privileges, start moving around, moving laterally around our cloud, and then get access to and steal a bunch of data. Then we're going to flip things around and talk about, in theory, what would you need in order to catch these kinds of things? How can you make sure that you're properly protected and make sure that the right preventive controls and detective controls and maybe even corrective controls are there so that you don't end up on the front page of the Wall Street Journal because all of your data got stolen? I hope you have lots of questions. We're going to save some time at the end before I have to hop in a cab and get to the airport and get home. Okay, so the first part of this is, what does the attacker see? You're going to see a few different screens. You're going to see a terminal window. You're going to see a web browser, of course, that's going to log into a variety of interfaces. Things are going to happen relatively quickly. I'll call them out and give you play-by-play as we go through this. My job is to provide context and clarity so that you understand what's going on. So here's what the attacker sees. So the first thing that we're going to do is we are going to do a basic scan. I've got a script that you just input a domain name, and it's going to go look for stuff, things that might be exposed. Specifically in this case, what this script is going to do is it's going to scan GitHub and it's going to scan Salesforce to see if there's anything at this domain that might be exposed. Doesn't find anything inside Salesforce. Nope, it does find some things in GitHub. What it found in GitHub was a repository that had some files that were open to the public. This happens a lot. If you use GitHub, your DevOps team might be using GitHub. They tend to put code there, of course. But sometimes they can inadvertently or on purpose expose things to make it easy to collaborate. In this case, what we found was a JSON file that has an authentication token, which is basically a login and password and set of permissions, right? So our DevOps person in this case, his name is Jerome. Jerome made a mistake. He left a file that had an authentication token that he was using to set up an API. This happens all the time. One of the CISOs we work with gave me a great quote the other day. He says, "Our DevOps team innovates at the speed of crap." They just want to get stuff out and stuff working. And with infrastructure as code, you can do that really, really fast. In this case, this authentication token is open to the internet. I'm the attacker. This is awesome. What is this authentication token? What can I do with it? Well, let's find out. So I'm going to copy this over. Spoiler alert, if you can read there, you can probably figure out what this authentication token is. I can see that it's an Okta token. So what I'm going to do now is go to this organization's Okta instance and see what I've got access to. I'm going to do that through an API. Most of what I'm going to do today is through APIs. Makes it a lot easier. And I'm going to use a tool to do that called Postman. Postman's an awesome tool for testing APIs. In this case, it's also an awesome tool for a threat actor. So what I've done is I've used Postman and I've called the API for this organization's Okta instance. And what I can see here is that this is a valid token, and I'm going to get the account details for it. It's a very simple API call, and I'm just going to copy and paste the token in. And basically what I'm doing is I'm programmatically going to Okta and saying, hey, Okta, what is this authentication token? What is the account that is associated with it? Well, you can see it's an active account. Jerome Boynton, I don't know why we made it, in this case, such a hard name to pronounce, but his name is Jerome. He's an admin. Yay for me. I now have the credentials in Okta of an admin. What am I going to do with that, you might ask? Well, I know that, first of all, this account is active, and I know it's an admin because the next API call that I'm going to make is going to list out all of the role assignments for this user. He is an Okta super admin. That's not that uncommon in this instance because, of course, it's a DevOps person whose one of his jobs is also administering our Okta instance. So I just plug in his ID into this API call. That's what's happening up here. Paste it in. There we go. Let's send. And you can see that, yeah, Jerome is an Okta super admin. That's great. However, as a threat actor, I probably don't want to start using this account. First of all, this token may not be live forever. Somebody may discover that it's exposed. Second of all, maybe our organization monitors privileged accounts. So I don't want to just use Jerome's account. I probably could, but I'm going to use Jerome's account to establish persistence. So I'm going to use the Okta API and create a new user. The names of these users are going to be important. So what I've done here is I've programmatically, through the API, created a new user, David Miller. David does not exist. David is now an account inside Okta. It's a valid account. I'm also going to assign superadmin to David. So now this fake person that I've created, David Miller, is also a superadmin inside Okta. That's going to let me do a whole bunch of other stuff in an account that might not be monitored as much as Jerome, who is our DevOps person. So now, programmatically, what I've done in Postman, I've never had to log into Okta yet. I've created a new user. I've made that user an Okta superadmin. That still doesn't give me access to any data, though, right? Okta is kind of like Active Directory for our cloud. Provides single sign-on and identity management and application assignment, but Okta doesn't really have any data. So even though I'm a superadmin in Okta, I still don't have access to anything interesting. But what happens when I log into Okta with David? Well, if I logged into Okta with David right now, he doesn't really have access to anything, but he's a superadmin, so he can start assigning applications. So I'm going to take David's login, and I'm going to go to a web browser, which is how we access all of our cloud apps, and I'm logging into Okta with David, and you can see I don't have access to anything. But I'm a super admin, so guess what? I can get access to everything. So now what I'm doing is I'm assigning David access to these applications. Now, what's happening here is as I assign the application, I am changing the credentials under which David is going to access these applications. Because while Okta has the user David Miller, none of these other applications, Box and Salesforce and AWS and everything else that I'm about to connect to, they don't have a David Miller account in them. Those directories don't have any idea who David Miller is, and I'm not an admin in AWS and Box and Salesforce, so I don't have the ability to go in and create those users. But you know who is a real person? Jerome. So when I assigned these applications to David, what I did was I gave David the application under the context of Jerome. What that means is when David logs into all of our cloud applications, he's actually logging in as Jerome. That's going to give me a whole bunch of fun stuff. So now David, in his Okta instance, has access to all of these applications, and he's going to log into them as Jerome, who is a DevOps person, so he might have elevated levels of access. Let's go find out. Wait, this happened twice. That's my fault. Created the backdoor use. Oh, I'm going backwards. Here we go. You can't give me a new clicker that I'm not used to. Okay, so what we saw was I found one file in GitHub. It had a token. I used that token to log into Okta. I used that access to create a new user. I assigned that user applications in Okta under the context of Jerome, who actually is a person. Now let's open up all of these applications and start our reconnaissance. What's happening here is I'm basically opening up every one of these in a new browser window so we can go application by application and see what David under Jerome has access to, or what really me as this attacker has access to. Let's use our access. The first one is maybe the easiest one. I've logged into Box. I've logged into Jerome's box. Jerome's an admin. There might be all kinds of fun stuff here. Stealing data in Box is basically as easy as right-clicking and creating a link, or I can download the entire repository. There's lots of ways to get these files out. I could do the same thing if this was OneDrive or Dropbox or G Drive or anything else. So I'm not going to belabor this one. This one's relatively easy. Logged in as Jerome. Now, Jerome's a DevOps person. He probably has a lot of really interesting stuff in his box. I might find more credentials. I might find other secrets that I could use to move laterally and get access to other apps. But I'm going to move on from Box. Now, when I logged into Salesforce, Jerome is a DevOps person. Jerome has absolutely no business need to have access to all of our accounts in Salesforce, because that's not what Jerome does. So when I started poking around in Salesforce, what I found was I actually didn't have access to anything interesting. Our Salesforce team has done a very good job of making sure that the profiles of DevOps people do not have access to potentially sensitive information like the accounts and other data within those accounts. I can see contacts, I can see some things, but I can't get to the really juicy stuff. So we'll come back to this later. Now, I want to see everything in GitHub. Not only do I have access to that one public repository or that one file that was shared publicly, now I'm Jerome inside GitHub, and I have access to everything in GitHub. And that is, again, a treasure trove. I could find all kinds of fun stuff here. I could even potentially even create my own supply chain hack if I really wanted to get in there and start modifying code. Now, let's figure out how to get access to data inside Salesforce. Because Salesforce has some really, really valuable data in it. It's got maybe trade secrets. It might have pricing information. It might have PII. It might have something that I could sell on the dark web. But in order to do that, I need to get access to the data that's inside Salesforce. And my profile does not have access. Anybody here ever been a Salesforce admin? A couple of hands went up. Salesforce administration is a beast of a job. Salesforce security is kind of in the dark ages these days. In order to get access to something in Salesforce, it's a combination of the permissions that you have in your profile, a permission set, or a group of permission sets, which is lovingly called a permission set group. There are also object settings, sharing rules, and mute permissions, and they all combine to give you access. So what I'm doing now is I'm looking at the profile of Jerome. Remember, that's who I'm logged in as. And when I go to his profile, I can see under these settings, and what's going to happen here is you're going to see all the various settings that are related to a profile. There are application settings, and there are system settings. You better make sure that all of these are set properly. Now, in this case, our Salesforce team did a good job. Our profile has no access to accounts, because there's no need for the profile of DevOps people to have access to accounts. But maybe I can fix this. If I fix this, what I'm going to do is I'm going to edit the profile. I don't have the ability to read, create, edit, delete, view all, or modify all, but I need to change that. So my profile does not give me access to accounts, but you know what my profile does let me do? I'm going to go and change one of the system settings inside Salesforce. Now, as a threat actor, what that's going to do is elevate my privileges. I'm going to use a misconfigured right to elevate my privileges here. What our Salesforce team did was they were more concerned about making sure that the accounts weren't visible. And they did a very good job of making sure that that profile could not access accounts. What they didn't do a really good job of, or maybe this profile should be able to change some settings, is this profile has the ability to change system settings. So I go into the system permissions here, and I'm going to change one very specific setting here. If I go down, scroll down, you better know what all of these are. If you want to make sure that your Salesforce data is protected. Scroll down, under users, I am going to give myself the ability, and you can see I have the ability here to manage profiles and permission sets. That means that as a user, I have the ability to change what this profile can access. And what I'm going to do here is make one very, very simple change under system permissions, and I'm going to give myself the ability to view all accounts. So now while my profile is set up, and by the way, when your Salesforce team, or when this company's Salesforce team goes in and does an audit, says, let's make sure that the DevOps people still can't access accounts, that's exactly what they're going to see. However, you will see now, when I go and look at my profile settings this time, come on, back out there. Now I have the ability to, I just clicked through to my account permissions. There you go, it's all checked now. So now, by changing one little setting, David, who is accessing Salesforce as Jerome, now has the ability to access all accounts. Let's go see what I can find there. Yep, there you go. Now I can see everything. And inside accounts are things like support tickets or price lists or quotes or even PII that might be in the attachments in some of these records. I have access to everything. And because Salesforce is a cloud app, it is as easy as going in. I could open up all of these individually if I wanted to. I could scroll through. I can create links that anybody on the internet can use because Salesforce, like everything else, is a cloud app. So exfiltrating data is as easy as simply creating links. And inside some of these accounts are going to be attachments that have PII. That's what I'm looking for in this case, because my goal here is to blackmail this company and get them to pay me so that I don't release a bunch of really sensitive data about their customers on the internet. I'm going to perform some extortion. You can see here I've created some public links. And now I'm going to go to an incognito browser window to validate it. There you go. There's all the PII that I found inside one account. If I really wanted to, I could probably dump their entire Salesforce environment. I could even do it through an API if I really wanted to. You know, 70% of all data flows these days are through APIs. They're not actually human created, it's just machines creating them. Make sure you're monitoring your APIs. Okay, that's Salesforce. Now let's move on to S3. How many of you use AWS? More hands go up. Yep. If you're using AWS, we're going to do a couple things in AWS. We're going to start with S3. S3, of course, is object storage. It is a great target for, or is a target for backups. Sometimes we do file backups in S3. It's the back end for lots of applications. In this case, we've got an application, or this organization that I am now attacking has an application that stores a bunch of customer data in an S3 bucket. I want that data. So I've logged into AWS as Jerome via David. And I want to make one of these S3 buckets public. This is how easy this is. So this is the AWS console. I log in. You can see there's my S3 buckets, and I'm going to select one of them, and I'm going to go to the policy. Amazon used to, way back, S3 buckets were public by default, and you had to turn it off. Now it's the other way around. So S3 buckets are not public by default, which is a really good thing for security, but it is relatively easy to make them public. So you can see here, everybody now has list access. And I'm going to modify the bucket policy. The policy is what controls the security to the bucket. There we go. I just pasted in a statement that is going to make that bucket public. Amazon is going to ask me to confirm this. There you go. I've got a URL. I go to my go to my browser window. There we go. Now I can list everything inside the bucket. But listing the contents of the bucket doesn't actually give me all, what I want. What I want is the data that's inside those contents. So now let's download all of these files. I can do this from a browser window, or I'm going to go back to my terminal and just do a couple of API commands to get this. So what I'm going to do now is I'm connecting to my S3 bucket. I am specifying that I'm not going to sign in because the bucket's public, so I don't even need to. There, I listed everything out. Now I'm going to download all of these files. I just went into one of them to validate there was something interesting in there. So now I'm going to sync this S3 bucket to my local machine. What that's going to do is take all of the files that are inside this S3 bucket, download them to my machine. Now you can see, there we go, I've got a folder, and all of the files inside the bucket, and lo and behold, hey, more customer information, more data that I can extort money out of this organization. What am I going to do next? Well, also inside AWS, there is a service called RDS. RDS is the Amazon's relational database service. It's where many of us are moving a lot of our on-prem databases or spinning up new databases. I want to steal some data inside an RDS database. So what I'm going to do now is I'm going to go from S3. I'm going to go back to my console. I'm going into RDS. This is a relatively simple process as well. So I find a database. You can see here, database 1. It's got sensitive data in it. I can do this for every single one. What I'm going to do is I'm going to create a snapshot of that database. I'm going to create a backup snapshot. And Amazon gives you the ability when you create a snapshot to send that snapshot to an S3 bucket. So that's exactly what I'm going to do. I'm going to export my database snapshot, so the copy of the database that I just made, I export it to an S3 bucket. And then I do the exact same thing. I can just steal, I can make that bucket public, and I can steal all the data within it. So just like I stole all the data from an S3 bucket, I've done that with an Amazon database as well. And I could do this for all of the application databases. I can do this for all of the object stores in Amazon S3. And now I've got the bulk of your data. So far I've hit files, I've hit application data in Salesforce, I've hit source code in GitHub, I've hit object data in Amazon S3, and I've hit structured data in databases. Some of you might be thinking, well, we only use some of these, or we don't use all of these. It doesn't matter. Once I found that Okta credential, I'm moving laterally to basically any cloud application that this organization uses. I could use this probably to get into Microsoft 365 if they were using it as well. What you're seeing here is he's walking through the exact same process to steal the data out of the database in the same way that he did with the S3 bucket. All right, and let's just see. All right, let's back up. How do you catch this? How do we put telemetry in place in order to detect and ideally prevent this kind of thing from happening? Well, first, go give Jerome a slap on the wrist. Don't make any of your source code public in GitHub. Well, that's already happened. That cat's out of the bag. So let's assume that our people, while they mean well, are sometimes going to make mistakes. You know, no phishing simulation is 100% successful. People will make mistakes, whether they're admins, users, business users, what have you. So how do you make sure that you can catch this kind of thing? The really important piece here is that you need to combine multiple types of metadata. Logging alone will not catch this. Just scanning for PII or other sensitive data will not catch this. Just doing posture management or configuration management will not catch this. Each one of those, the behavior, the logs, the authentication behavior, and the data access behavior, the visibility into what data is sensitive, like PII, whether it's in an S3 bucket, an RDS database, a Salesforce record, or a file that's in Box. All of that is very critical, as is the permissions. What do our users have access to, as is the configuration management. Like, think of that one misconfigured setting in Salesforce that allowed me to elevate my privileges there. So you need to combine multiple streams of metadata, multiple types of metadata together, because each one gives context. If all you have is logs, well, you don't know where you're at risk and you don't know what you need to fix. If all you have are configurations, well, then you're not actually watching anything, and it's very hard to know when somebody's behaving strangely. So the key thing here is, as I walk through this, is we are going to combine multiple kinds of metadata together in order to get context. Here's what this can look like. The first thing is to identify exposure. Now, the big exposure that led to this entire kill chain was a misconfigured GitHub repository that allowed that file to be accessed publicly. This is the kind of thing that's relatively easy to identify if you are scanning for it. Now, this kind of exposure is going to be different in GitHub than in Amazon, than in Box, than in 365, than in Salesforce, because the ways that data are exposed publicly are, of course, different for each one of those cloud applications. What does it mean for something in Salesforce to be exposed publicly versus something in GitHub to be exposed publicly? So what you need is the ability to look in all of these different places and translate the configurations, the entitlements, the permissions together to identify that exposure. And in this case, we find that there is a GitHub repository that is open to the public. Now, inside that public repository, we have additional context, because there is a digital secret. That authentication token is something that we could identify. So now you can combine the fact that you know what might be exposed or what is exposed with what is also sensitive. Those two things together give you a good target from a security perspective about where you have a broken preventive control. We found an exposed repository. That might be fine on its own. We found a digital secret. That might be fine on its own. It almost certainly is fine on its own. Put those two things together, and we have a potential disaster. Next, we see an unexpected user that was created via an API. How do we know that this is unexpected? Well, you may have APIs create users on a regular basis. In Okta, maybe, maybe not. Maybe it depends on how big you are. We generally don't see a lot of programmatically created users in a system like Okta. So that would be kind of weird on its own. So in this case, we see that it not only was a user created, that happens all the time, but a user was created through an API. This might be worth looking into, but what's really worth looking into is that this user that was created via an API was granted extremely powerful rights. In this case, super admin inside Okta, also done through the API. So you put those two things together, an analysis of the rights that were given, so a classification of identities along with an analysis of the behavior. So we're providing context by different kinds of metadata, and suddenly we see something that sticks out like a sore thumb. A super admin created via API. That's weird. Let's go take a look at it. Now, the impersonation. The reason I spent so much time talking about Jerome creating David and then giving David applications, but doing it under Jerome, was that that is really, really strange. It generally doesn't happen, especially in an end-user identity management platform like Okta. Why is this user being granted access to applications under the context of another user? Maybe it happens once, maybe there's a reason to do this, but generally, when you're granting somebody access to an application, it's going to be using their own credentials or their own account in wherever that application is. So in this case, we did a classification of identities, and we see the behavior that uses that classification to identify something strange is going on. We see that a user is being assigned an application in Okta with a different email, assigned under a different email. We should also be able to dig into these logs. So you're almost certainly throwing these logs somewhere, maybe into a SIM, maybe into another kind of log aggregator. In this case, we want to jump down and see very specifically the events that triggered this alert. And you can see here, if I jump to the log, I'll see the XML of the log itself. And here is where you will see, I believe it's going to scroll. Yep, there is David, the user David. And let's scroll down to the alternate ID is Jerome. So this is the single event. What's tricky here is that you need to, it's not just the fact that you've collected this log. You need to be able to analyze the log in this particular way. You need to be able to process and normalize that log. Just because you had the event, and this is a single event, the application assignment from one user under the context of another user, you need to analyze your logs in a way that tells you this is something strange. So it's not just about gathering the logs, it's about looking at them critically. Now, the attacker checked his access. Remember, we opened up all of these applications in our browser window. That happened in a couple of seconds. That's not really that normal. Maybe some of you, when your computer turns on in the morning, logs in and just opens up everything that you have access to. Mine does it. That's too many browser tabs. I have browser tab anxiety. I like to keep it kind of trim, and I don't have tons and tons of tabs open. But in this case, David connected to an unusual amount of applications in a very short period of time. Maybe that is totally benign. Maybe it's not. It's probably something that you want to go look at. Let's see these activities. You can see here's him connecting to all of our different applications. There's Box. I know this is hard to read in the back there. Box, Google, GitHub, Salesforce, and AWS. And of course, he's connecting to those applications under the context of a different user. We should be able to hide unrelated actions. Sometimes finding the needle in the haystack means getting rid of hay. Also, beware of anybody who tries to sell you on the idea that you will catch threats by collecting more logs. That's like finding a needle in a haystack and just throwing more hay at it. You need to be able to separate signal from noise. That's critical when you're detecting these kinds of threats. Here's, if we want to, we can dive in and see the specific log items. In this case, you're seeing that David is the one performing the action, but of course, he's doing it under the context of Jerome again. That is also weird. So it's the access to the applications, not just the assignment, and the access is also happening under another credential. Which, if it was supposed to happen, would be totally normal, but again, this is the kind of thing that generally doesn't happen. Another thing to keep in mind here is that I'm looking at individual events. A lot of us start with a threat detection program that looks at thresholds of activity. If I see lots of data being downloaded, or if I see lots of sensitive data being accessed, or if I see lots of network traffic, that is certainly useful. But in this case, no threshold-based alarm the only threshold-based alarm that triggered was this user is accessing a bunch of applications in a short period of time. But in general, this is kind of low and slow, even though it happened pretty quickly. It's low and slow because there's not a high volume of activity, but it was really dangerous. Now we see the privilege escalation. This is inside Salesforce when David, as Jerome, our threat actor, went in and started changing settings and getting access to lots of data. So you can see here is, I know it's hard to read, Jerome enabled modify all documents. That's a very specific setting inside the system permissions of a profile that allows that elevated level of access. Again, this is a single event. That was a single click. A threshold-based alarm would not trigger on this kind of privilege escalation. Now we see that Jerome, now this is a threshold-based alarm. Jerome went and accessed a bunch of Salesforce data. Remember, when he was looking, when we were doing the kind of the reconnaissance inside Salesforce, he opened every single account. That is weird, and that is a threshold-based alarm. This is also something that you can identify if you have normalized profiles for what users normally do. or even APIs. What do they normally do? So when they start deviating from their normal patterns, in this case, Jerome accessing, now remember, this is Jerome, even though David was doing it, he's doing it under Jerome's context. Jerome is a DevOps person, never accesses any accounts. Why is he suddenly accessing all of our accounts, especially after a suspicious privilege escalation? One of the things that we see a lot in security is that, yes, I would be alerted on X or Y. I would be alerted on a lateral movement. I would be alerted if it was Active Directory on a Kerberos. I would be alerted on a golden ticket or a pass the hash. But the next question that's going to get asked is, what happened next? So when the privilege escalation happened, was any data touched? What was actually accessed? Oftentimes, we can't answer that question because we don't have enough of the right kind of metadata. So Jerome went and accessed all these Salesforce objects. You can see here's everything that he touched. You should be able to do this. You should be able to answer the question, what data was actually touched? What did he access? Not just for answering the positive side of this, so that you know, for instance, what customer information was touched, but sometimes this is really valuable for the negative. We know that there was a threat actor in our system. Can we prove that no PII of our customers, for instance, was accessed so we don't have a notification event? It can dramatically reduce the cost associated with a breach if you can answer this question, because you can say, yep, we know that no customer information was accessed, so we don't have to notify everybody. Versus, we don't know, so we have to notify everybody that their PII may have been accessed by a threat actor. Two completely different orders of magnitude of cost when it comes to breach investigation and cleanup. Now, combining multiple types of metadata like sensitivity with activity would also tell us not just when something sensitive was accessed, but when something sensitive was, or lots of sensitive data were accessed. So in this case, Jerome went in and found an attachment that had PII of some of our customers in one of those Salesforce records, and he created a link to it and accessed it. So that is a single log item, but that log item has the context of this is an event on data that was also sensitive. All of those things are important in order to determine that Jerome is accessing a lot more sensitive data than he ever has before, because of course he never has accessed anything in Salesforce, because up until a few minutes ago, he didn't have access to anything in Salesforce beyond basically the ability to log in and see some contacts. So here is the actual file that I touched. We know it's sensitive, and if I want to, I should be able to answer the question, who could have done this? Who could have accessed this? Who had access to this data? What we've done here is we've looked at the profiles, the permission sets, the permission set groups, the object settings, the sharing rules, and the mute permissions of every object inside Salesforce, combine all that together to answer the question, all right, who could access this data? And in this case, there's lots of people that have, you can see, read access to this file that has sensitivity. One of the things that you should be thinking of if you want to put more effective preventive controls in place to make sure that this kind of thing doesn't happen is, where do we have valuable information? Who and what has access to it? And is that the right level of access? The tricky part these days is that you've got data on premises, you've got data in the cloud, you have data in all these various places, and the ways that a human or an API or a service account could get access to something is incredibly complicated. So answering those questions, especially if you have to do it on your own and go into each application one by one and go to each permission setting one by one and go to each file one by one, we'll never do that. It's just way too much work. But if you're gathering the right metadata, you can. In this case, I know exactly where this file is, I know exactly who has access to it, and I know exactly what kinds of sensitive data are in it, because I have gathered all of the entitlements, the configurations, the permissions, and the sensitivity of all of our data in our Salesforce environment. Here you can see all of the events on that data. This is the third key piece of metadata. So not only are we scanning for sensitivity, not only are we measuring posture and exposure and permissions, we're also monitoring behavior. And you can see here, here's everybody who touched it, including our attacker right there at the top of the list, Jerome. So what's interesting here is when I'm doing an investigation, I know that Alan Carey, who's the only other person who's ever touched this, is probably the owner, knows what this is. Jerome sticks out like a sore thumb because, of course, he's not he's not a business user. He is, again, a DevOps person. Why is he accessing sensitive data? This should stick way out in an investigation. You should be able to answer these questions really, really quickly. But of course, the exfiltration didn't end there. We then pivoted to AWS, and we grabbed the context of an S3 bucket, and we grabbed a database. So let's sum all of this up. A very minor misconfiguration. In this case, it was a GitHub repository that was accidentally left public. That one misconfiguration led to a series of steps in a kill chain where lots of really, really sensitive and important information was taken. So one little thing can lead to disaster. It's kind of like the, one little crack in the dam can lead to a flood. Lateral movement is different in the cloud. We used to think of lateral movement as going device to device or server to server or network to network. Lateral movement in the cloud is really going application to application, and it can be done programmatically because every single one of these cloud apps has one or more APIs that are exposed by design, because that's how we integrate things together. That's how we get more value out of these cloud apps. For those of you that have Salesforce, you may now be experiencing the fact that any new application that you bring on board, somebody's going to ask the question, where and how does this integrate with Salesforce? Because we want everything to talk to each other. But that means, because everything is exposed via APIs, a threat actor can take advantage of that. And if you combine metadata from multiple sources, of multiple types, sensitivity, behavior, posture analysis, permissions analysis, all of this is important, then you can identify exposures, you can identify threats, you can identify where there are preventive controls that are lacking that'll lead to this kind of disaster or lead to this kind of attack. It'll also put you in a much better position to do two things. Lower the time it takes to catch a threat, time to detection, and lower the time it takes to investigate, respond, and recover from it. Time to recovery, time to reaction, whatever it might be, TTD and TTR. Those two factors directly relate to or directly speak to the effectiveness of your threat detection program. Because if those two numbers are too big, if you catch something really quickly because you're gathering tons and tons of logs, but it takes you forever and a day to investigate it, how useful is it? On the flip side, if you never see the threat and this threat actor is wandering around your cloud environment undetected, well, that's just as dangerous. You need to lower both of those factors. So it's not just about time to detection. It's also ask yourself, how long would it take for us to piece together exactly what happened? And one of the things that I find interesting about this particular kill chain is that there is no single log that you could have looked at to tell you the complete story. You can't just look at the Okta log or the GitHub log or the Salesforce log or the AWS log or the Box log. Each of those is critical in piecing together exactly what happened. But if you have all that telemetry, that investigation actually wouldn't have taken very long. You could have answered all those questions probably in a few minutes, and then you would have known exactly what to do. So, what should you do in the next 6 to 12 months? If you haven't yet, do a posture assessment, risk assessment, start mapping all of the configurations on all of your cloud applications. If you're not looking for sensitive data in your cloud applications, you probably should start. The number of healthcare providers that talk to us that say, we don't have any PCI data. Of course you do. Trust us, we'll find it. Do some sort of risk assessment. You don't need to use us to do it, but if you haven't, do it. Do a purple team if you haven't. Have someone do a pen test or a red team, but also have your SOC or threat detection or data protection team on the other side. Figure out what telemetry you have and what might be missing. What questions could you and could you not answer about how a threat actor got in, moved around, and stole your data? And the last one seems kind of basic, but none of us like implementing compliance controls. But if you eliminate exposure, if you put good preventive controls in place, if you're monitoring everything, including with the context of what's sensitive and might be regulated, then it makes it easy to prove that you have good detective and preventive controls in place. The corrective controls, like automatic responses or automatically fixing misconfigurations, can be exceptionally valuable. We often hear that not every organization is ready for automated corrective controls, but it can go a long way towards being a force multiplier for your security team, because the single, I used to ask CISOs what keeps them up at night, but I always got the same answer. It's not what I know, it's what I don't know. And also, I can't hire anybody because there's nobody out there and I don't have enough budget, and we have open head count everywhere. There's not enough time and people to go do all of this on your own. So leverage automation where you can. I think now I've got 2:40 on my watch, right? And I'm supposed to go until 2:45. So we've got 5 minutes for Q&A. How did I do on timing? I got the big thumbs up. Do we have any questions? Yeah. Sorry, I'm going to walk over because I can't hear you. Yeah, so the question is, would it be realistic to detect and prevent this in real time? So The answer is yes, depending on how you define real time, right? So at what point do you take action and what action do you take? The correct action in this case was probably to disable the David Miller account, right, in Okta. That would shut down most of this access. It should. But when do you do that? So do you do that when you see, for instance, the alert on the GitHub repository? Probably not, because there was no David Miller account there. Do you shut down Jerome's account because his authentication token was used to log into Okta and then create another user? So the word real time becomes tricky. The answer is yes. If you have the right telemetry and all of these alerts are being generated in near real time, all of these alerts could potentially have taken some sort of action. The question becomes, what action do you want to take automatically? Usually, in our experience, the only time you would do some sort of automatic prevention, like take a very specific action, is ransomware. When you see a human being behaving like a machine and encrypting data, you don't want to wait for someone to get an email and look at a dashboard, and you just want to shut that down. The tricky thing with these is that, and this is why I tried to emphasize, each one of these events on their own is kind of innocuous. It's when you see the string of them together. I don't know if that's a very satisfying answer. The answer is yes, but you have to be very careful about where you want to put automation in place. Automation can be extraordinarily valuable, though, for the corrective controls, right? So when we see an open GitHub repository that's got a digital secret in it, just fix it. Just lock it down. Then this never happens. It's like you went back in time and you stopped it from ever happening in the first place. You can do the same kinds of things for the Salesforce settings. So when we see that misconfiguration in a profile, just fix it. I don't want to wait. Our Salesforce team has a policy. These should be set this way. If it ever deviates, if we see the drift, just automatically shut it down. Same thing, if an S3 bucket ever gets made public, shut it back down. Don't even wait for someone to go decide, because none of our S3 buckets should be public. It depends on the organization, depends on your kind of risk tolerance for automation. So the answer is yes, but it depends kind of where in the kill chain you want to do. Yeah. So is the question, are the alerts built in, or do you? So that depends on who's generating the alert. So the question is, are the alerts built in, or can you customize them? It might not surprise many of you to know that what I was showing you was one of the Varonis interfaces, because this is how we do it. All of those alerts are out of the box. They can all be customized, as can the classification patterns. That said, it depends on how you're alerting. So if you're trying to do this in something like a SIEM, like Sentinel or Splunk, you have to do a lot of work on your own in order to do that and to minimize noise. With us, it's mostly out of the box, but yeah, you can customize them. You can also customize the actions that you take. It depends on where you're getting, what's analyzing the telemetry. I would worry about any system where you couldn't do that, because then you'll end up with noise that you can't tune out. And if your alerts are noisy, guess what? You're never going to look at them. Alert fatigue is a real thing. As are findings fatigue. Be aware of anybody that gives you findings and doesn't give you a plan for what you're going to do when you have the findings. If I show you all of your open data, where all your sensitive data is open, and then you ask, well, what do I do next? And I say, well, that's your problem. Well, how useful is that? Findings fatigue is a real thing. Great question. How effective is generative AI in creating those kill chains? The answer is super effective. ChatGPT, write me some malware, write me some ransomware. The answer is yes. It's made the job of a threat actor even easier. It makes our coders more effective. It makes every coder more effective. It makes the threat actor's job even easier than it was before. Super, super, super effective. Because generative AI generally knows those APIs really well, right? Especially the newer LLMs that are like GPT-4 that doesn't go back, it's basically scanning the internet in real time. So it knows those APIs. It's incredibly effective at writing code, which means I don't even need to know how to use these APIs. I can just have ChatGPT do it for me. So the question is, would I agree that this is not a shrink wrap solution? I'm paraphrasing. And that it would take some time and effort in order to get to the point where you would get this level of fidelity. Is that fair? If you had asked me 3 or 4 years ago, I would have said you're 100% right, and it might be a couple of months before you get this. Now I'm going to talk specifically about Varonis. Everything that I just showed you is deployed as a SaaS. Our incident response team is available at no additional cost to our customers. They do all the alert tuning for you. All of these alerts that you saw were out of the box. There's absolutely no tuning required. You would start to see these on day 1, maybe day 1.5. And if we see any noise, we'll tune them out. Also, because it's a SaaS, we see your alerts. So if you're not looking at them, we are. We'll just call you. One of our goals as a company is to go wide into new places. Another goal is to add more automation. And another goal is to, as much as possible, minimize the time before you can see this kind of thing. So the answer is, you would see this realistically in 2 or 3 days. From multiple pain points. We will connect to every single application I just showed you. Every alert that I just showed you and the interface of diving, that's Varonis. That's what we do. Yeah. I'm not supposed to give you a product pitch, but here we are. All right, I think I'm getting kicked off the stage. Thank you all very much for coming out on a Friday. Appreciate it.